is Tash Hepting. I'm a senior systems architect in the office of the CTO. Basically, think about wireless all the time, come up with the next big idea.
How does real-time location services fit into the grander scheme of network security?
Well, there's been a lot of news recently about real-time location systems and some of the stuff that we've done with our acquisition of Newberry. One of the things that has me really excited is that a real-time location system is just one piece of the puzzle. We've been working on building an authentication engine that'll take a bunch of different pieces, location being one of them, and allow you to improve your security in a variety of different interesting and dynamic ways specific to your application. So an example of this would be, the RF firewall that we've already talked about before, where you take the user's physical locality around the network and use that as a component of their authentication and their access rights. Well, you can take other pieces. You can take the time of day. You can take what the user is currently doing on the network and combine them in very novel and new uses. So an example of this might be if you're in a university. You've got a professor who's concerned about cheating during tests, doesn't want students to have to be able to go off onto the internet, look up answers, but still wants to do some sort of electronic delivery of the tests. Well, what you could do is by taking the authentication piece for real-time location, the authentication piece for time of day, and say if the student is in this particular auditorium from 3 p.m. to 5 p.m., an ACL firewall rule is placed on them that basically says they are allowed to access this set of resources, they are denied access out to the internet as a whole. Gives you an interesting and different level on the authentication. You can also use it to help in administration of your network and kind of like automatically monitor certain behaviors and compensate in the network for it. Another thing that tends to happen, especially in university environments, it's a large contention for resources, and sometimes you might run into a couple of people who are bad network citizens. They might be consuming a level of bandwidth far in excess of what other people are, and could be interrupting voice services or clogging bandwidth further up the pipe off the wireless network, for example. And you can do a lot of things to prioritize different levels of traffic, and everybody can do that at this point, and that's great. But if you fall into the same priority queue with this bad network citizen, you're still going to have a reduced experience. So one of the things that you can do with the Trapeze system is make the network actually aware of how much bandwidth the user is using, and then specifically and dynamically throttle them. So you could set up a rule on our SmartPass network authentication engine that says if a user consumes more than X number of megabytes in an hour, gigabytes, whatever unit you want, it will notice that in real time and dynamically change that user's authorization and throttle them down. That guy's obviously doing some crazy file transfers, who knows, could be peer-to-peer transfers, whatever, could just be copying lots of files, but we can take him and move him down to the background queue. So he's going to affect everybody else even less. We could actually massage his bandwidth down and constrict him to his particular bit rate. You could expand on that even further. We're taking one puzzle piece here, but what if you wanted to say that, off hours in the dorm, it's a free-for-all, go for it. Well, you can set up your network access rules in SmartPass to do that. You could have other areas of the campus where, maybe even if it is off hours, there is still some restrictions on there, and, put the pieces together, set up the thresholds, configure it once, and you're done. And at that point, your network has now become aware of what the users are doing on the wireless network, and you've set up some rules for automatic compensation, and you've taken normal authentication and security and taken it from a all or nothing, they either work or they don't work, and added some granularity into it so you can actually determine what they're doing and how they're doing it. It's a really great technology.
It sounds very complicated to set up.
It's really not that bad. SmartPass has a GUI. You go in and literally you're taking these puzzle pieces together where you're saying that if time of day matches this and this, and you set together a series of rules. You say and this and that, set your conditions, save it, and then it sits there, runs in the background constantly. There's a little bit of configuration ahead of time, but it's really not that bad. And once it's running, you don't need any intervention at all. It does everything completely automatically. And actually, another thing that's quite cool and above and beyond what most other people do is that the enforcement, when it takes effect, happens in real time. So sometimes you'll see other products where, especially if it's entirely a radius-based implementation where they're trying to do some of this functionality in the radius server and there's no tight integration between the wireless system and the radius server, you have to wait for the user to roam and re-authenticate again before they'll get the new rules from the radius server. That's not good enough. We don't do that. We actually have a system where SmartPass, using a standard, it's called dynamic radius, standard IETF RFC, it will automatically inform the entire mobility domain that, hey, this guy's authorization attributes have changed, and they'll take effect immediately.
Thank you very much, Tasha. I really appreciate the information.
You're welcome.